what we want to do is we want to look at two different definitions, a relation and a function. A relation is just a set of ordered pairs. And so it's just a matter of grouping some things together. Now remember, ordered pairs are like X, comma, Y. So if we know that a relation is a set of ordered pairs, we want to start looking at these groupings and defining them more specifically. That's where our second one comes into play, and that's called a function. A function is described as a relation, but it's where every input has a unique output. Or we could say our x's can't repeat. So we're going to look at two examples, and we're going to expound upon this definition of function and look at it in different modalities as well. The first one we want to look at is a function with ordered pairs, just these little groupings here in these examples. So if we look at this, we can see that here's x being 1, 2, 3, 4, 5. And so this is known as a relation. By all means, it is a set of ordered pairs. But what we want to know is it a function? So by looking at that 1, 2, 3, 4, 5, the fact that each of those x's are only listed once, they are not paired with anything else, we would also say that this grouping is a function. Now, if we look at the next one, we see that when we start looking at ordered pairs, this has odd, even, odd, even, odd. And we'll note that odd and even are listed more than once. So the fact that these x values are repeating, although this is a relation, it is not a function. Because at first, we thought odd was going to be paired with 1, but over here odd was paired with 3 and with 5. And so because those inputs had different outputs, it's not a function. Now, looking at ordered pairs is not always the fastest way of figuring out if something's a function. So we're going to look at functions on a graph and see if we can take the definitions and look at those definitions in the graph and approach it a different way. So in the next one, we look at it and we say, okay, let's look at something called the vertical line test. The vertical line test says if any vertical line that's drawn on the graph crosses more than once, then it is not a function. Because if it were to cross more than once, that's going to go in and that's going to say, again, your x's can't repeat. So we're looking for the x not repeating, but the way we're going to look for that is by drawing vertical lines. So if I come in here and say, you know what, if I draw a vertical line, say right here on this curve, you can see that it's only crossing once. And I could draw vertical lines anywhere on this graph, and it's still only going to cross it once on this curve. And so because it does not cross it more than once, we know that our x's are not repeating, and so we could say that this is a function. Now, if I look at the next example, we're going to look at the curve, and we're going to say, okay, is this a function? So we draw a vertical line anywhere on the graph. If we draw one here, you can see that it only touches at this point, which is fine, but we're looking for one bad line. We're not looking throughout the function and seeing, or the equation, the curve, figuring out if we find one line that works. We're seeing if any line possibly drew, crossed it more than once. And so you can see if I were to draw a line here, it would cross here and here. So therefore, this one would not be a function. In the next example, you can see if we were to draw a vertical line here, same situation, it's crossing here and here. Again, you might make the debate of, well, what about here or here? Those lines work. Well, and that's good that they do, but you're looking for the entire curve if any vertical line crosses it more than once. So again, in this one, it's not a function. So we can look at if something's a function in ordered pairs. We can look at if something's a function on a graph. A more specific type of function we could consider is a one-to-one function. So the fact that it's being one-to-one is a very specific type. So with a function, we said that x's can't repeat. Well, with a one-to-one function, we say x's and y's can't repeat. And so how do we figure that out? We do that by the horizontal line test. With the horizontal line test, what this is making sure it's doing is that every x maps to exactly one y. So let's still look at the curves, and we're still going to follow the same process from above. First, we're going to make sure that it passes the vertical line test. So you can see anywhere I'm drawing a vertical line, that's going to pass, and that's going to be a function. Let's go ahead and just go through and do all the functions. Again, we could draw a vertical line anywhere on the graph. It's only going to cross it one time at the curve. So again, this one's a function. Next one, we would say, okay, again, vertical line here and here. That's great that works, but you can see any vertical line that we draw here in the middle is going to cross it more than once. So therefore, this is not a function. So therefore, it's no reason for us to check if it's one-to-one. So we say not one-to-one. So that's kind of a shorthand for writing that. Now let's go back and let's look at these other functions and see if they're one-to-one. So I'm going to erase these vertical lines just so it's kind of cleaned up a little bit for you. And so I'm going to look at it. Okay, if I drew a horizontal line, you can see it crosses once. And that's well and good. You can see I could draw a horizontal line down here. That crosses it once. The problem is when I draw that horizontal line here in the middle, any of these functions are disqualifying it because it's crossing more than once. So this is not one-to-one. Looking at this middle one here, again, I'm just going to kind of erase my vertical lines. You can see if I were to draw a vertical line anywhere on this graph, it's crossing it only once. So out of all three of these, this is the only one that's one-to-one that's going to pass that vertical line test, but also the horizontal line test. So we've looked at ordered pairs. We've looked at graphs. Let's look at another area. These two areas we're going to look at, we've got the first diagram with areas, and then we've got the table. Still looking for, is it a function or is it one-to-one? So let's have some reminders. For a function, our x's can't repeat. That's just kind of our shorthand for checking that. If it's one-to-one, x and y can't repeat. So first, let's check if our x's are repeating. To see if your x's are repeating in a diagram with the arrows, you're looking for only one arrow coming out of your inputs. These are called inputs or x values. And so in this case, the fact that all the arrows are coming out, only one arrow, this is a function. Again, you look at all of your inputs or your x values. Again, this is a function. Well, you got to have a bad example, right? So you can see the difference. Do you see how there's two arrows coming out of that Q? We would say not a function. Now, because this does not qualify as a function, it's also not one-to-one. We're not even going to check that area. Let's go back to the beginning. X's and Y's can't repeat. So with red, we checked if the X's repeat. Now we're going to check the Y's, or these are also called outputs. They can't repeat. You see right here on this one, two arrows are going into N. So what's happening is ordered pairwise, that's PM, QN, RN. So your X's didn't repeat, but you see right here, your Y's repeated, and that's kind of shown by these double arrows coming in. So this one is not one-to-one because our Y's repeated. You can see all these have only one arrow coming in. So this is a one-to-one function. Just for fun's sake, we'll look at this one. You can see that those all have Y's, one arrow coming in. So that means that the Y's aren't repeating. Now it's still not one-to-one because it has to be a function first. So I just want to kind of show you in a different area on how that can be shown. On these two tables down here, these are just a whole bunch of ordered pairs. This would be like ordered pair 3, 5, 14, 0, etc. But again, same test. We say if it's a function, your x's can't repeat. And then we say if it's one-to-one, your x's and y's can't repeat. So let's go through and check all this. So here's all of our x values. And you can see that none of those are repeated. So yes, this is a function. Now we'll continue looking at this one. So now we look at our y's. Did our y's repeat? But do you see how 5 is here and here? So that means we're pairing 3 with 5. So 3, 5. And 15 with 5. So that would be like a double arrow situation. Because 3 and 15 are both paired with a y value of 5, we would say this is not 1-to-1. Now in the next table, something unique happens. So we look at our x values and we see that 6 repeats. But when you look at your y values, 3 repeats. So really what's happening here is the ordered pair 6, 3 is being listed twice, the exact same ordered pair. So that means 6 didn't get paired with any other number. 3 didn't get paired with any other number. So this is actually one where it's a function and it's 1-to-1. So if you see a repeated value, check its output or its y value, because if it's the exact same ordered pair, that just means we listed it more than once, not that it got paired more than once like in the other cases. And so these are all the different ways that you can see whether it's a function or a relation or a 1-to-1. Now what we want to do next is we want to look at function notation. This is when instead of writing y, we start writing f of x. This is known as y is a function of x. So if y is a function of x, here's how I would kind of explain it. F of x is like its formal name. It's like your birth certificate name. Y is like the nickname. Now we use y and f of x interchangeably because they both mean the same thing. But what happens is that function notation actually tells us more about what's going on. It gives us a way to write things more compactly, put instructions in there. Math people are kind of lazy. That's when we have formulas and shorthands. We do letters to represent unknowns, etc. So let's see how this function notation is going to work out for us. When we're evaluating a function, we want to look at it graphically and algebraically. So first, let's look at it graphically. You'll notice that instead of x right here, they're calling it a 2. So that means that this is your x value. It's saying where on your graph, when x is 2, is your curve. And you can see that it's right there. So this would be equal to that corresponding y value, so 1. So f of 2 would be equal to 1. 1 is the y value that pairs with that. So you see how that was kind of a shorthand to ask you to find what x equals 2 is on the curve? The reverse of that is they say f of x equals 4. Since it's equal to 4, that is telling you that this is the y value. So go to where 4 is a y value and find where that curve is. So we see it here and here. So then we would say, well, it has a y value at, I'm just dropping down to the x-axis, x equals -1 and x equal to 3. So you can see from this function notation, they were able to give us x values and y values in a different way, ask us to look at instructions, and all they said was to evaluate. And so we're just reading the graph at those values. Now, algebraically, what's going to happen is it's going to show you how to plug in for it. We see that here we have h of p is equal to this equation, and they asked to evaluate at h of 4. So that means everywhere you have a p, you're now going to be plugging in 4. So the best way to approach this is, if you're looking for h of 4, is to rewrite your equations with blank parentheses anywhere you have a letter. Then take the value that you're plugging in. So in this case, we're plugging in 4 and put in 4 to its spot. Once you have everything plugged in, what you want to do is you want to pull up your calculator. And so I'm going to switch over to my calculator here. And so you can see that I've already plugged this in. So I went in here and I used parentheses appropriately. I want to make sure I have parentheses anywhere I had that letter P. It's going to output the answer for me, and that's going to be at 24. So I can say equals 24. Now, you want to be careful when you're doing this, because if it had said, what is h of -4, again, follow the same process. Do your parentheses to recreate that equation, but put blank parentheses anywhere you have the letter P. Then go back in and plug in -4 to those parentheses. You want to do that because over here, if I were to put in -4 into parentheses, you can see it's going to give me 8. If I come down here and I do -4 squared plus 2 times -4, that gave me -24. Because order of operations, it's going to do your exponents first, and it's going to apply that squared to whatever it's touching. In this first one, it's touching the parentheses. In the second one, it's touching the 4, and then it's going to add a negative on. So it's very crucial that you do not do this second way. You always plug it in with parentheses. And so we can see in that one, we can grab our answer. That was 8. And so just say equals 8. And just want to kind of cover how to input that. Now, some things do get complicated. Let's go into this next example here. And in the next example, you can see that we are looking at plugging in 2a and then other variations. So we're not going to get scared. We're just going to follow our steps. So instead of x, they have us plugging in 2. And so I'm going to say, number 1 here, f of 2. First thing I'm going to do is I'm going to rewrite that equation with blank parentheses anywhere I had an x. Next thing I'm going to do, this was a 2 they're telling me to plug in, so I'm going to plug in 2 into all those blank parentheses. Now in this case, we're going to follow suit like we did before. We're going to go to our on-screen calculator. This is provided underneath each of your homework problems. And we're just going to enter that the way we saw it. So we had parentheses 2 squared plus 3 times 2 minus 4. So that gives me a value of positive 6. No big deal. That just followed suit from our previous example. Now in the next one, they have a plugged in. So instead of x for f of x, we're going to be plugging in a. So I'm saying, okay, well then number 2, f of a. I'm going to follow my same procedure. I'm going to draw my blank parentheses. And then anywhere I have parentheses, I'm going to plug in what they assigned it. And in this case, they assigned a. So I'm going to say a. So again, this is the only thing that I have changed about this problem. I've just changed all my x's into a's. Now in this one, there's not any cleanup I can do. I can't plug it in a calculator, so this is just a squared plus 3a minus 4, and that's my answer. And that's okay to get an answer that's not just this perfect little number. Number 3, they amp it up a little bit. F of a plus h. So again, they have changed their x to an a plus h, so I'm going to follow my same steps. Open parentheses squared plus 3 times open parentheses minus 4. I'm going to plug in the a plus h into my parentheses, and then I'm going to simplify this up. Now with this one, I can actually square out this a plus h. I'm just going to multiply the two groupings together, bring down everything else. So I can distribute, which gives me a squared plus ah. Distribute this way, which gives me ah plus h squared. It doesn't matter the order. 2 times 4 is the same as 4 times 2. So whether I write ah or ha, the order is not going to matter on multiplication. Now on this back one, I'm going to go ahead and distribute. This gives me 3a plus 3h minus 4. And then what I'm going to do is I'm just going to kind of clean this up and combine like terms. So I have a squared. I have this ah, 2 of them. So I'm going to say 2ah plus h squared. And it looks like I can't put any of these terms together because the only way I can add them together is if they had all the same letters and exponents. So part 3 was more difficult, but I only had to do 2 things. FOIL or distribute, multiply out the a plus h squared, and distribute the 3. Step 4, we're going to put this all together. So they want us to do f of a plus h minus f of a all over h. But we've already done the legwork for this. Here's f of a plus h, so I'm just going to take that answer. Minus f of a, so I'm just going to take that answer. And then I'm going to put it all over h. So I'm going to take my answer from part 3, a squared plus 2ah plus h squared plus 3a plus 3h minus 4 minus f of a, which is part 2, a squared plus 3a minus 4. I'm going to divide that whole thing by h. Now, if I go through and clean this up, I'm going to have to distribute this negative throughout this back parentheses so I don't lose it because I'm subtracting the whole thing. And then when I go to canceling in here, you can see that positive 4 cancels with negative 4, negative 3a cancels with positive 3a, negative a squared cancels with positive a squared. So this actually simplifies down into 2ah plus h squared plus 3h over h. Again, I'm starting to know some similarities. These all have an h involved. So I'm going to factor that out. So I get h. So I'm just unmultiplying it. 2a plus h plus 3 all over h. So my h's would now cancel because I have that multiplication set up in the previous step. I had it as addition pieces. So this simplifies down into 2a plus h plus 3. Now, I know this is the hardest thing that we've done within this video, but it's really putting together a lot of our skills and reinforcing the fact of this function notation. You can plug anything into it and kind of manipulate through it. Go and attempt the homework. If you have any questions, please reach out through Canvas messaging, and we'll be happy to help you.